Hi, welcome to another video in my series on mathematical induction, where I'm going to show you how we can use induction to prove results for matrix multiplication. And I've got an example here where we've got a matrix M is equal to 1, 0, 3, 1, and we've got to prove that M to the power n is equal to 1, 0, 3n and 1 for all positive integers n. And if you're not sure about mathematical induction, what we do is we first of all show that it's true for n equals 1, then we assume it's true for n equals some positive integer k, say, and go on to show that it's true for n equals k plus 1. And then based on that assumption, if it's true for n equals k plus 1, then since it's been proved true for 1, it must be true for n equals 2. And if true for n equals 2, it must be true for n equals 3, and so on. In other words, for all positive integers n. So let's just start then by saying that when we have n equals 1, let's see what we would get through this for m to the power 1. So we would have m to the power 1 equals 1, 0, and then we've got 3 times 1. I know that's going to be 3, but I'm just going to put that in there to show that I'm actually using this particular matrix, okay? And we can see that that then comes out to 1, 0, 3, 1. And therefore we can see that agrees with what we had originally. So we can say that therefore true when n equals 1. Now we go on to assume that it's true, assume true right here, for n equals some positive integer. Let's say we call it k. And on that basis, we've therefore got m to the power k equals, if we come up here, letting n equal k, we're going to have the matrix 1, 0, and then 3k, and then 1. Alright? Now, we need to look at what happens when n equals k plus 1. We've got to go on and try and show that this is going to be true. So we've got m to the power k plus 1. Well, what's that going to be? Well, it's the same as m to the power k multiplied by m. And if we come down here, let's just write out what m to the power k plus 1 is going to be. Well, as we've seen here, it's m to the power k, which we've got here. We've assumed that it's going to be that result. So it's 1, 0, 3k, and then 1. And we multiply that by m being 1, 0, 3, 1. So 1, 0, 3, 1. So when we multiply these matrices out, what do we get? Well, it's always rows times the column. So we do 1 times 1, which you know is 1, plus 0 times 3, which is 0. So you're going to get 1 there. And then top row, n column, so it'd be 1 times 0 is 0, plus 0 times 1 is 0. So we've got 0 there. And then if we do the bottom row, first column, we've got 3k times 1 plus 1 times 3. So in other words, 3k plus 3. And then bottom row, n column, 3k times 0 is 0, and 1 times 1 is 1. So 0 plus 1 is going to be 1. Now, if it's going to be true for n equals k plus 1, what am I going to expect to see? Well, I'm going to expect to see, wherever there's an n, a k plus 1. So I'm going to have 1, 0, 3, k plus 3. If I actually expand it out, 3 bracket k plus 1. And you can see I can get that from here just by factorising this term here. So if we just do that, we've got 1, 0, and then in the bottom here 3 bracket k plus 1, and then we've got the 1. So you can see hopefully that this is now true for n equals k plus 1. So let's just summarize up in the usual way, and we can say that if true for n equals k, then what we've been able to prove here is then it is true for n equals k plus 1. And we've already seen that since true for n equals 1, let's just put that in, since true for n equals 1, then it must be true for n equals 2. Okay, so for n equals 2, the next one up from 1. And if true for n equals 2, it must be true for the next one up from 2, 3, and so on. So in other words, it therefore must be true for all positive integers. So for all, let's just put that in there, for all n is a member of the positive integer set. Okay? Well, I hope that's given you an idea then on how we go about doing proof by induction when it comes to matrix multiplication. And this is the first in my example. I've got another one which is a bit harder that I demonstrate to you. But as usual, if you want to see more tutorials, always go on my website, and there's an index there, or if you're doing a particular examination board, generally I've got that examination board also up there for you to look at the tutorials. Okay.